Forces do not only affect an object's motion, they can also affect an object's shape, causing a deformation. This is what happens, for example, in a spring that is fixed on one end. If we apply a force, the spring is either compressed or stretched. We may notice two things. First, the spring returns to its original shape when the force is removed. Second, the size of the deformation is proportional to the force. This relation is known as Hooke's law. The constant of proportionality between the force and the deformation or elongation of the spring is called the spring constant, and it is a measure of the spring's stiffness. The higher the constant K, the stiffer the spring. Note that, contrary to other forces that we have studied, the spring force is not constant. It changes with the spring's elongation. When the spring is stretched or compressed, the force in Hooke's law is doing work on the spring. This work increases the spring's potential energy. To obtain this potential energy, we can use the fact that the spring force is a conservative force. Therefore, the work will only depend on the initial and final position of the free end of the spring, and this work must be equal to the change in potential energy. Entering Hooke's law into the integral for the work, we can thus obtain the expression for the spring's potential energy in this way.